Hi everyone. Today we're going to go through converting from moles to grams and grams to grams in a chemical reaction. So this is stoichiometry just continued here. And I believe this is lesson 2.11. So 2.10. So, or sorry, 2.11. This is lesson 2.11. Okay, so remember, in chemistry, we always work through the mole. And of course, this is a very, very important concept. Need to make sure you remember that, okay? So for this, you always have to make sure before you can go anywhere, you go through the mole. And the analogy here is if you are on, I'm curious who this person is. If you were on the Seaford side, Seaford, and you want to get to the Maple side, you have to go through the Commons, over the bridge, or you could go through the link, right? But you can't bypass those areas. You have to go through them if you want to get to the other side of the building. And so we can say that this middle ground here is like the moles. So if you want to get to the other side of the school, you have to go through the mole, okay? Now, here we go. Okay, so we're just going to work through some examples here. So calculate the mass of magnesium chloride produced from 0.356 moles of lithium chloride and unlimited magnesium nitrate. So first up, we're going to write the equation here, and I would give this to you. So we've got lithium chloride plus, and then we have magnesium nitrate. So magnesium nitrate is becoming, and now this is a double displacement reaction, so lithium nitrate plus magnesium chloride, which is MgCl2, and I need a 2 here and a 2 there. Oops, I forgot the 2 there. And I think we're balanced here. Yeah. Okay, now when I do these, I always write down the information that I'm given underneath the chemical equation. It just keeps everything really nice and organized here. So I know that I've got 0.356 moles of lithium chloride, and the question is asking me to find the mass of the magnesium chloride. So this is my grams over here. Okay, so that's what I'm looking for. Now it tells me that I have unlimited magnesium nitrate, and what that means is that you don't need to worry about that, right? So don't pay attention to the magnesium nitrate, not important to this particular question because you have as much of it as you need. So looking at this, I've only got 0.356 moles of lithium chloride. How many grams of magnesium chloride can be produced from that? So we're going to use dimensional analysis. So grams of magnesium chloride equals, and then I write down what I know. I know that I've got 0.356 moles of lithium chloride. Now, moles of lithium chloride has to go on the bottom. Okay, so whatever you write here, that has to go to the bottom here. I'm just going to erase that there. Okay, so what goes on top now? Now you want to get to grams of magnesium chloride, but before you can get to grams of magnesium chloride, you have to get to moles of magnesium chloride. So moles of MgCl2 goes on the top, and the ratio between them is going to be 1 to 2. Okay, so I've got 1 mole of magnesium chloride for every 2 moles of the lithium chloride here. So if you stopped your problem right now, your moles of lithium chloride would cancel, and you're in moles of magnesium chloride, but you don't want that. You want grams of magnesium chloride. And so we put 1 mole of magnesium chloride on the bottom, and in 1 mole of magnesium chloride, how many grams are there? And this is where we go to our periodic table, right? So 35.5 times 2 for the chlorine, plus the magnesium, which is 24.3, and this is going to end up being 95.3 grams, and that comes from the periodic table. So now let's just check our units: moles of lithium chloride, moles of lithium chloride, moles of magnesium chloride, moles of magnesium chloride. I end up in grams of magnesium chloride, and then let's do the math on this. 0.356 multiplied by 95.3 divided by 2, and my answer is 16.9634 grams. But I look here in the question for the sig figs, and I can only have 3 sig figs in my answer. So I'm going to either put a bar across there, or I'm going to round this to 17.0 grams. Okay, and that would be, the magnesium chloride here. Okay, so looking at this, I had 2 brackets, right? So going from grams to moles is going to require 2 brackets for me. Next one, calculate the mass of NH3 produced from 1.2 grams of H2 in an excess of N2. So this is, we're going to have our H2 plus N2 becoming NH3. So looking at this, I'm going to write down what I know under, well actually first of all I'm going to balance it. So I'm going to need a 2 here and a 3 here. Now it's all balanced. So now I'm going to write down the information that I'm given. I'm told 1.2 grams of H2. 1.2 grams of H2 and an excess of nitrogen, which means I don't need to worry about it, and it's asking me to calculate the mass of NH3, so grams question mark for the NH3. So now I can go through and do the math on this. So I'm going grams to grams. So I want grams of NH3 equals, I know that I've got 1.2 grams of H2. So right away, grams of H2 goes on the bottom, and what goes on top? Moles of H2, because I have to convert that first into moles of H2, and this is going to be 2.02. So if you stop the problem right now, your grams of H2 cancel, you're in moles of H2. You don't want moles of H2, you want to get to grams of NH3, but before you can find grams of NH3, you have to get to moles of NH3. So moles of H2 goes on the bottom, I want to get rid of that. Moles of NH3 goes on the top, and now I look at the ratio between them, and it's going to be 2 to 3. Okay, so that is the mole ratio in the middle there, 2 moles of NH3 for every 3 moles of H2. So now if you stop the problem, you would be in moles of NH3. You don't want that though, you want grams. So 1 mole of NH3, and on the top is going to be my grams of NH3 here. And this, I'm going to take 1 nitrogen and 3 hydrogen, so this is going to be 17.03 grams of NH3. So now I'm just going to cancel my units out here, make sure I'm right. So grams of H2, grams of H2, moles of H2, moles of H2, moles of NH3, moles of NH3. And you end up in grams of NH3. So let's figure this out. So I've got 1.2 times 2 times 17.03. And I'm going to divide that all by 2.02, divide it again by 3, and you get an answer of 6 point. Well, let's actually check my sig figs first. Only 2 sig figs. So 6.7 grams of NH3 for this particular answer here. So grams to grams, again, I'm going to have 3 brackets there. So how do the brackets work? So typically 1 bracket is when we go mole to mole. 2 brackets is moles to gram or grams to mole. This would be in a reaction, okay? And then 3 brackets, this is when we go grams to grams. So sometimes that's helpful for people to remember here, just if you're using dimensional analysis, how many moles you need of them all here. Okay, you can try assignment 16 and 17. You have the answers already. I think they're, yeah, one of them's already on there and one of them's posted on the website. So take a look at the assignment and see how you do. Thanks, everyone.